So we'll finish off chapter 1 doing infinite geometric series. So we've looked at the idea of geometric series and what it is, but we're going to look now at ones that are infinite. And by infinite, I mean that they go on forever. So for example, it says an infinite geometric series has an infinite number of terms. It is said to be convergent if its sequence of partial sums approaches a finite number, and divergent if not. So convergent if it approaches a finite number. So it means it's going to get smaller, like we're adding, and by the time that we add that point 0.000000000 is going to approach a finite number, but it's going to diverge if not. So if I'm taking 2 and I'm multiplying it by 2 and multiplying it by 2, it will actually go to infinity. It's not going to converge, it will diverge. So here's the formula that we're working with. R has to be greater than 1. We've talked about this already. If not, we're dividing by 0. And n is really big. So it virtually becomes equal to 0. So the idea here is if I take 1 minus r to the power of n, this value is going to become so big that it's going to virtually be equal to 0. So if n is equal to infinity and r is bigger than -1, but smaller than that positive 1, so it's not equal to 1, then we can just use the formula here. So we can actually drop that 1 minus r to the power of n. So let's have a look. So for just time purposes, I have this one filled in. So for this one, it says to find the limit of the following infinite geometric sequences. So the limit, so it's going to be no more than, or it's going to converge to what? So I have my series that's infinite. My T1 is my 4. 1 minus r. So if I'm looking for my difference, I can do the 16 over 25, and I'm going to divide it by 8 over 5, which is multiplying by 5 over 8. That becomes a 1, that becomes a 5, that becomes a 1, that becomes a 2. So we end up with, and that should be 2 over 5. I think this one must be this one, or I just forgot the 5 there. That's okay. So 1 minus 2 over 5, so we have 4 divided by 7 over 5. So I'm multiplying by the inverse, so 20 over 7 would be the limit, the sum that would be the limit for that series. Same idea over here. I have my series again. If I'm looking for my r value would be 10. And because my r value is 10, and I found that by dividing one by the other, there would be no limit, because r is not smaller. So remember, we looked over here. If r is greater than -1 or smaller than 1, then we can do our limit like this. But if r is greater than that, there would be no limit. This one would go on and get bigger and bigger and bigger and bigger forever. So this one is asking, if the pattern continued, will the area of the shaded portion have a limit? So the idea is that this pattern would then continue. That I could go in here and I could make another square, and then I could make another square, and we're looking, what is that limit? So I know that my initial area is going to be 50 centimeters. I know that if I take these 4 triangles that are shaded in, and I'm going to do area of base times height divided by 2, so that would be 5 times 5 divided by 2, that would give me that area of 50 centimeters squared. And then my second area, if I wanted to figure out what is going to be my area of these 4 together, so I'm still going to do that 4, but if I have this length would be 1/4 of this total length, which would be that 2.5 times 2.5 divided by 2, area of a triangle, multiplied by 4, so I'd have 12.5 centimeters squared. And then I have the first 2 terms. I could continue on, but I have enough here to find that r value. So I would have that 2.5 divided by 50, which would give me 1/4. So yes, there would be a limit because my r value is smaller than 1. So I can go and I can actually calculate that limit by looking at my T1, which is 50, and I would divide it by 1 minus 1.4. So I'd essentially have 50 divided by 3/4, so I'd be multiplying by 4, dividing by 3. And this would give me, if I simplify, 200 over 3 centimeters squared would be the limit. And then finally, the sum of the following infinite geometric series has a limit. So they're giving you your geometric series, and they want to know what x is if the sum of the limit is 2 minus 3x. So essentially, we have the 2 minus 3x, and we know the first term is equal to 4. We want to know the value of r here, and you could write that as x if that makes life easier, but I'm going to multiply both sides by that 1 minus r to get rid of that in my denominator. And if I multiply this out, I'm going to end up with 2 minus 3r, oops, sorry, it should be a 2. Let's just get rid of that. So I'm going to end up with 2 minus 2r minus 3r plus 3r squared is equal to 4. I can rearrange this and I end up with a quadratic. 3x squared minus 5x minus 2 is equal to 0, so I just brought everything over. And then we're just factoring. If I factor, I will end up with 3x plus 1 and x minus 2. And then I'm looking at an x value of either positive 2 or an x value of negative 1/3. So it's asking to determine the value of x. It would have to be this. This would be too large to actually have a limit. So all I did here, just to kind of backtrack a little bit, I have my, and I changed it to x. Sorry, force a habit. So I did my 3x squared. This together would give me my 5x squared. This together would give me my my negative 2. Actually, really, I should go back in and change all those to r's. And then remember factoring. So I'm looking in this case for two numbers that are going to multiply together to give me that negative 6, and that are going to add together to give me that negative 5. So I can make, and you could do whichever method you wish, but I'm looking for negative 6 and negative 5. So in this case, I would be looking for negative 6 and positive 1. So I put those in. Remember, with the cross method, you have to do 3r plus 1, and then I would do 3r minus 6, and then I'm dividing to simplify that out. So I end up with 3r plus 1, and this would be r minus 2. So that's how I got this value here. And then my two values of r, I would have to have an r value of negative 1/3 for this to have a limit, and it is telling me it is. So I do have to reject one of my possibilities.